In this presentation, I'm going to show you a film and TV workflow that uses several of the applications in the Media Entertainment collection, specifically 3ds Max, Maya, Mudbox, Sketchbook, and Recap. I'm also going to touch on the Arnold 5-pack, which is now available with the M&E collections. Here's a movie of the shot that we're going to be building using those tools from the Media Entertainment collection. We're going to start off our workflow presentation inside of Sketchbook. Because this is a plan view, we can use symmetry by changing the layer. This can easily be toggled on and off during the sketching process using marker menus. One of the main reasons artists love using Sketchbook is the speed and feel of the brushes, especially large airbrushes. Next, we can cut back the fill using the hard erase brush. During the sketching process, we're constantly adding new layers. Here's a new layer that isolates the airbrush work used to simulate shading or lighting. Sketchbook has circle and French curves to assist your sketching, letting you tighten up your sketch to a more formalized concept sketch. Next, we're going to add the details that establish the scale and purpose. This is done using JPEGs or PNGs with alpha that can be sourced anywhere. Sketchbook allows you to quickly and easily place, fit, and modify the images. Here's a good example of the workflow of an image that's scaled and then distorted to simulate the curvature of the surface falling off. It is then cut back using the hard erase tool. Next, we mirror the work to the other side and adjust the layer settings to overlay the graphics and let the shading come through. The eraser's refinement continues by adding some damage to the layers, and the blend modes are adjusted. The blend modes are familiar to any artist who's used tools like Photoshop. Here we're adding in some flow lines that help establish the direction and movement in the sketch. The red looks cool, but it's a bit strong, so we can tone that down by using the HSV tool. Sketchbook also has a text tool that you can access any font that's installed on your system. So that's just a quick example of how we can use Sketchbook to do a concept drawing in this workflow. So the next thing that we want to do is generate a new background asset to use in our animation. The Media Entertainment Collections comes with Recap Pro and Recap Photo. These are both applications used to generate assets from everyday objects. In this example, we're going to be using Recap Photo to generate an asset of these cliffs that was derived from drone footage. The first step is to upload the images to the cloud to compute. With the cloud compute finished, we can now download the asset to begin working with on our local workstation. So let's go ahead and open that model in the PhotoRecap editor. And as you can see, we have some data in the scene, but its position and scaling hasn't been established correctly. So that's the first thing that we want to address. We'll go into our model settings, into our transform model, and we're going to use pick a surface. This allows me to select a face to use as the up axis or the Y vector of that piece of geometry. So with that done, I can further refine that using some basic translation tools. So we'll kind of move this guy down, push it back a little bit further into the plate, and then we'll go ahead and we'll drop that guy and rotate it around ever so slightly to better establish the overall orientation and position of that object in our scene. So now that we've done that, the next thing we want to do is establish the scale of our scene. And we're very fortunate to have a couple of assets in the photogrammetry, specifically these cars that we can use to establish the scale of our scene using a simple units command. So this allows me to select 2 points in my scene and specify the distance between those. So instead of being 0.21 meters, I'm going to tell it this is more like 5 meters. So as soon as we do that, we've now established the overall scale of this piece of geometry correctly. So the next thing that we're going to do is go ahead and start to use some of the higher level tools inside of PhotoRecap's editor to modify this geometry or refine this geometry. So we have tools for doing things like retopologizing the surface, as well as some basic editing tools for doing slicing operations, some smoothing operations. These are brush-based tools, as well as some filling operations that allow us to fix defects in the geometry. So these two holes right here, we want to smooth across or fill in so that they're no longer there. And you can see that Recap goes through and does a beautiful job of that. So now we have a pretty high quality piece of photogrammetry that we can export out to start using in our next phase of our project. When we export this, we have a few different options. We can export an image, a turntable animation, or for this example, we're going to export out a model, specifically an FBX model, because we want to send this off to the next phase of our project, which is animation layout. So we'll go ahead and we'll select that FBX file, and we'll just simply export this guy out. Now we're going to begin laying out the animation. Now this can obviously be done in 3ds Max or in Maya. In this example, we're going to be using 3ds Max. I've already got an early version of my ship imported into the scene, and I want to combine that with that cool recap data of the cliffs that we just generated. So we'll import in the FBX file. With the cliffs and the ship both in the scene, you really get a sense of the massive scale of this environment. The first thing that I want to do is lock down these cliffs so they don't accidentally get translated as I'm animating my ship and my camera. So we'll just go ahead and toggle on the frozen switch for that node. Now as soon as we do that, they turned gray, so we just need to change the properties on that node so that they stay shaded even though that it's currently frozen. So with that done, the next thing that we want to do is get a new camera in our scene that we're going to animate panning across these cliffs as the ship flies by it. So we're going to create a new camera from our perspective's current view. So with that physical camera created, if we go over to a 2-up mode, you can see that we now have a camera that has 2 nodes, a target mode and the back of the camera. And if we look at the back of the camera down its length here, you can see that the film gate or the aspect ratio of this camera is a very old school 4:3 aspect ratio. So that doesn't really feel very cinematic. What we want to do is we want to modify some of the properties to make this feel a bit more cinematic. And I can make this a bit more clear by turning on the safe zones down here in my lower panel for that actual camera. So we're going to jump into our render settings and we're going to change our output size to be something a bit more cinematic, like a 235. So it's worth noting that in my render settings, my renderer is set to use Arnold. Arnold is super awesome. It comes both in Maya and in Max in 2018, and we're going to be diving into that a bit more later on in this presentation. So now that we've got all of our setup done, we can begin laying out our shot and starting to block out our animation. So the first thing that I want to do is I want to grab all of these nodes and I want to kind of position them a bit further down my scene here and a little bit higher up so that we kind of get a sense of that ridge line as this camera is kind of flying past all that information here. So we'll just kind of grab all these nodes and scoot them down here to the left a little bit. And maybe we'll just grab the tail end of that camera and we'll just give it a little bit of push that way so that we really get a sense of that parallax happening on that recapped data. And this really sells a shot of why we're using true 3D assets as opposed to just background stills, because it just makes such a difference when you're doing these types of moves. So with all that done, we're going to go ahead and select all of these nodes and we're going to set some keyframes on them. So we're going to basically make sure that set key is turned on. We're going to change our tangent type to be linear. So we don't need ease ins and ease outs on this. And we're just going to go ahead and set a keyframe on all of those objects. So now we can move forward in time to the tail end of our animation, and we're going to grab all of this information again, and we're just going to kind of scoot it down here toward the end of our cliffs. And I'm going to grab the tail of this camera and kind of push it that way so it just sort of does this little whip pan kind of happens on that guy. And maybe we'll grab the ship, and on that guy we're going to give it a little bit of rotate and kind of put it up on its knife edge, maybe raise that up a little bit in frame there, and we'll kind of push that guy off of camera so that it flies way off camera as that's happening. So we'll grab all of those nodes and we'll just keyframe that. So with that done, we can start moving our ship back here to the beginning of our animation. And I do want to have this ship start off frame. So we're just going to grab that guy and we're going to modify our first key. So in a few seconds there, you can see how we were able to really quickly start to lay out our animation of this kind of camera pan happening across those cliffs and that ship just kind of blasting by. And that looks really pretty sweet. So obviously the next step is to start to add some more visual complexity to our scene. And we're going to be using Mudbox to help us texture this ship. So let's jump in there and check that out now. The next step in our workflow is adding more visual complexity to the racer. And this is done in Mudbox. Mudbox is an awesome tool for sculpting and texturing based on industry standard workflows. Artists can choose to use either a UV-based workflow or a p-text-based workflow. The first step in the process is adding a new layer to the diffuse channel and setting a base color. Next, we're going to add in some basic shapes and colors with brushes that have mirroring enabled. Brush stamps and paint stencils can be created from images that are imported, including PNGs with alphas. During the painting process, stencils can quickly be fit to the model using hotkeys to adjust the scale, position, and orientation. By adding detail, we're helping establish the scale of the vehicle and making parts of the ship have a sense of purpose. As you can see, we can work with individual layers and they can be adjusted and blended together. Now we can use the stencils to add some damage and imperfections to the specular channels. Layers give you the ability to quickly iterate on your design ideas. Here we're using the HSV tool to try out different color ideas. After the painting and texturing is completed, the artist saves out the FBX file to bring the data back into 3ds Max or Maya. Here we are inside of Maya where we're going to be finishing off this animation. We're going to be doing the final look dev and using Arnold 5 to render out the ship and the environment. Arnold 5 is jam-packed with many new features and I'll be highlighting a few of those along the way in this presentation. It's now shipping with the 2018 versions of both 3ds Max and Maya. Furthermore, the Arnold 5 pack is now available with the M&E collections. And this is 5 full licenses of the Arnold renderer, so you can use it with both Max, Maya, as well as Cinema 4D and Houdini. So I'm going to go ahead and load up a flipbook to give you an idea of what the lighting model and the shader looks like for this ship that we're trying to get to in our presentation. So this is just a quick turntable that I put together to see how my lighting model was working and the shaders on the ship were behaving. It's lit very simply by using a high dynamic range image probe that was derived from the same location that the photogrammetry was taken. I've got an extra directional light added into the scene to give it a little bit more pop and a little bit more control. The shaders on the surface of the ship are using the new AI standard surface shader that ships with Arnold 5, and this is an awesome shader. It's really a Swiss Army knife of a shader. It's got a few advantages. It's super fast, it's very efficient. It also has the ability to accurately represent many different types of materials, as you can see on the surfaces of this ship. So here we are back inside of Maya, and I'm going to walk you through the process of setting up the lighting model as well as the shaders on the ship. The first thing that we want to do is get ourselves back down to the origin. So we'll jump over to our perspective mode and zero out the animation to bring the ship back into frame. Now, as I previously mentioned, the lighting model is pretty simple. It's basically an AI sky dome and a directional light. So we'll go ahead and we'll create that AI sky dome, and we're going to map to its color and high dynamic range image of the actual cliffs. So we'll go ahead and we'll grab that file now. Now you'll notice that when we bring this file in, because this is an HDR file or a 32-bit float file, Maya's going to look to the color space rules, and it's going to automatically change our color space from sRGB to RAW as soon as it loads in that .hdr file. It would obviously do the same thing for a .exr file. So now that we've got that in there, the next thing that I want to show you guys is the hardware lighting. When we go ahead and hit 7 on the keyboard and enable hardware lighting, you'll notice that Viewport 2.0 now has the ability to use that AI Sky Dome as an image-based lighting source inside of the viewport, as well as a reflection source inside of the viewport, which is just super, super cool. So the next thing that we're going to do is add into our scene another light. This is going to be our directional light that's going to allow us to really adjust how strong that sun's going to be and give the scene a little bit more pop. So with that directional light in our scene, what we want to do is we want to use this directional light to try to match as best we can the overall lighting direction that's in that background piece of geometry. Now, if you remember, that background piece of geometry was developed using Recap, so it's all based on photography, so that lighting's been baked in there. What we want to do is make sure that our synthetic objects match as best they can to that background object that's obviously all based on photographs. So with that done, I'm going to go ahead and just dial in a few of the parameters in the Arnold section for this directional light. We want to use Arnold's color temperature source of something like 5600 to kind of get a nice midday sun, and I'm going to overdrive that exposure to something like a value of 1.5. Now I've got a little Mel script saved out that's going to go ahead and further refine that light's position and orientation just to kind of line it up exactly where I want it to be for my final renders. So the next thing that we want to do is just make sure that our sky dome is also positioned correctly. So we're going to kind of look up here toward the sun, or where the sun should be, and just rotate that sky dome around until that sunspot starts to line up with the direction of that directional light. And I've got a little Mel script that's going to also kind of dial that in a little bit more precisely. So with that done, we can go ahead and just drop our exposure down a little bit in our scene here. You can see that Viewport 2.0 does a really pretty nice job of giving me a good representation of what this is going to look like before we even commit to a software renderer. Now with that said, obviously to start to really dial in the subtleties of the shaders, we're going to want to get Arnold up and running. So let's go ahead and check that out now. So here we are, we've got the Arnold view kind of pulled up, and I'm going to just jump over to my Hypershade view, and you'll notice that the shaders that are associated with the ship, we'll grab these two guys right here and we'll just graph those, are just basic blend materials. So let's just go ahead and get IPRs up and running on this guy. So with that done, you'll notice that Arnold is going to be rendering in the background as I'm working. For the rest of the demo here, we're going to have Arnold kind of constantly, progressively getting more and more refined in the background. And this is one of the things that's so impressive with Arnold 5 is the speed. I mean, it's just crazy fast. The fact that I can sit here and move around my scene and actually interact with it as that renderer is running and doing this, extremely high fidelity quality render is just simply amazing to me. Arnold 5, super, super cool. So what we want to do is we want to start to further refine these shaders. Now, as I said before, they're okay. They're just blend shaders that came in with the textures from Mudbox. So they don't look super good. So what we're going to do is we're just going to break all of these connections, and we're going to switch these guys over to that new AI standard surface shader, which is my go-to shader now. It really is a Swiss Army knife shader inside of Maya as well as 3ds Max with Arnold 5. So as soon as we make that an AI standard surface shader for both of these pieces of geometry here, you can see that the ship automatically starts to look much more photorealistic. It's extremely cool looking now. So what we're going to do is we're going to go ahead and just drag and drop our texture maps onto their channels, as well as start to dial in a few of the parameters here for the specularity. So let's just kind of scooch this guy over here, and we're going to kind of focus all of our energies on dialing in the back half of this ship's shader. So we'll kind of zoom out there. We're a little tight on that guy. So the AI standard surface shader, as I mentioned before, has a lot of control. The first thing that I want to draw your attention to is the fact that it has two different specularity models. It's got a specularity model as well as a clear coat or top surface specularity model. So this allows you to do things like create car paint really, really simply. So we're going to kind of focus our energy on this first specularity model. So obviously, if we start to increase the index of refraction, we're going to get more and more reflections in our scene. It's going to get much more of the environment showing up in there. That's a little bit too extreme. So we'll go back down to a value of something like 1.5. If we play around with the roughness, what's going to happen is that's going to give us a broader highlight. And that's exactly what we want to get for this kind of car paint look. We want to have a really kind of broad highlight happening within a secondary clear coat kind of hot specular point happening on top of that. So we'll start to dial in a little bit of the weighting on that second coat, that clear coat on top of that guy. And we might even put that roughness down to a value of something like 0.05 just to make that even more tight. So as we start to scrub through this guy, you can see the effect of those two different specularity models sort of working on top of each other. So now that we've got that kind of basic understanding of how this shader is working, the next thing that we want to do is we want to start to dial in the contribution of this dirt map. We want to use this dirt map to start to not only break up the diffuse color, but to also break up the specularity. So the first thing that we're going to do with this guy is map this into our main color. So we're going to basically just put that into the color gain, which is essentially a multiplier. So by doing that, you can see that we now have a lot of noise in this environment. It's like really scratched up, and it's a little too extreme. So we want to tone that down using a couple of the utility nodes inside of Maya. So I'm going to create a color correct node. So we'll just hit the tab key and start to type out color. We'll get the color correct node in there, and we're just going to kind of daisy chain these guys through here. So we're just going to substitute that so that it's passing through that color correct node. And what I want to do is I want to lessen the effect of the midtone. So to do that, we're just going to jump back into that color correct node, and we're just going to pump that gamma up to something like a value of 3 in the red, green, and blue values. So as soon as we do that, you can see that it now starts to look a little bit better, but we've lost a little bit of the blackness in that area that's really super damaged. So to fix that, what we're going to do is we're going to go ahead and add in another node. This time we're going to add in another contrast node, a simple contrast node. So we'll just go in here and kind of grab that guy. So with the contrast node brought up, we're going to drag and drop the color correct node into that guy. And now we're going to substitute what used to be the color correct node with the contrast node that's passing through it. So as soon as I do that, you can start to see the effect of that actual contrast node. Now, if I really wanted to fine tune one of these modifiers or one of these manipulators, I could go ahead and solo that. And as soon as I click the S on this and solo it, you'll notice that in the viewport, it's now gotten rid of all of the shading contribution, and it's isolated out just that map. So I get the pure color of what that map is doing. So if we go ahead and do something like put the bias up to something like 0.6 across the red, green, and blue channels here. Oops, looks like I got that put to 1. Let's go to 0.6 on that guy. You can see that we've now got that black spot having a little bit more contrast in there. It's kind of pushed the black levels up a little bit. Now, at any time, if I wanted to see, any of these objects soloed, I can just go ahead and click the S button. So this is the unmodified original map. This is going through the color correct node that's kind of lifting the mids, and then we're going to go ahead and look at the contrast node, which goes and kind of pushes those extreme scratches and brings those blacks sort of back up. So that looks pretty cool. So the next thing that we want to do is we want to use this same type of map to go ahead and adjust the weight of our top clear coat. So what we're going to do is we're going to add in this color correct node going into the weight of that guy. So that kind of break that specularity up a little bit using that guy. And what we want to do is we want to refine the overall roughness of this piece of geometry on that clear coat from a low value to a high value to kind of get those scratches to show up a bit more. So you'll notice that 0.05 is sort of the range to 0.4 that we were using. So where there's dark areas, we want to have a very broad highlight, and where there's light areas, we want to have a very tight highlight. So we need to inverse this color range of this map. How do you do that? It's really easy. You just use a reverse node. So with the reverse node set up, we'll go ahead and we'll map this guy into that guy, and we'll take the out color into the input for that. So now we've got that range reversed. The next thing that we want to do is we want to modify the value range that it's using. We want to keep that full kind of gamut of colors, but we just want to, or range, but we just want to limit them from being the old range that used to be black to white, 0 to 1, down to something that's going to be good for that roughness value, which is going to be something like, 0.05 or 0.01 to 0.4. So how do we do that? We just grab another utility node, and this time we're going to use the set range node. So with set range, we can just drag and drop this guy into the value, and we're going to only be using a float value out of this. So we only need to play around with the X attribute. So we're going to say old max was 0 to 1. Our new min is going to be 0.01 to something like 0.4. So now what we're going to do is we're going to take the out value of just the X, and we're going to pipe that into our coat roughness. And as soon as we do that, you can see that we really start to get that breakup happening on that specularity. Now, this might be a little bit too extreme. I'm going to go back to the set range, and we'll put that to something like 0.05, and that's going to broaden that highlight up, or maybe even a value of 0.1 might look a little bit better. Yeah, that looks kind of cool. So now you can see that we've got this really nice effect happening, and I might want to tone down the overall color balance of this color correct node here a little bit more. It's a little hot. So something like that starts to look pretty cool. So I've got a couple of other shaders on this chip that have been a little bit more refined. So I'm just going to go ahead and use a mel script to assign those guys. And you can see this is what the final shaders look like after I've kind of dialed those guys in, and we get this really nice specularity kind of moving across that with both a broad highlight and that really tight highlight, and you get these little kind of scratches and things like that kind of just ever so slightly showing up in that kind of broken up specularity, which is really pretty cool. So the next thing that we're going to do is jump back to our camera that is our shot camera, and we're going to jump an IPR window over to that same shot camera, and you'll notice that as I scrub through my time slider, IPR has the ability to actually just keep up and update this guy. And this is insane to me. Like, this is that layout of the animation that we did in 3ds Max, but now we're seeing it like actually in the renderer, in this unbiased render. And if we just let this sit and rest on a frame, it's going to progressively get more and more refined, and it just looks super cool. So the next thing that we want to do is we want to go ahead and launch this off as a batch process to render using that Arnold 5-pack. So this is pretty cool. What we're going to do is we're going to jump over to our rendering menu, and I'm going to go into the rendering setup, and I can basically start a background job using Backburner. So what this is going to do is it's going to go through and find all the render nodes that I have on my local network. It's worth mentioning that the collection also has the ability to render both on your local network and on cloud. You have cloud rights with the M&E collection. And we're going to be using this background renderer to basically go through and utilize all the assets that I have in my facility. So we'll go ahead and we'll submit the job. And with that done, if we bring up the render manager here, you can see that it just queued up that Dreadnought Racer demo. And as that's rendering off on my render node that's at my house here, I can actually still continue to work on top of this file. And that's really the beauty of having those Arnold 5-packs, is it allows you to keep your interactive session of Maya going while you're batch processing and rendering on your remote machines and on your render nodes, which is just super cool. So thank you so much for taking the time to check this out. If you guys have any questions, please reach out to either myself or Mike, and we'll be happy to answer them as best as we can. Cheers, everybody.